Hello guys, in this video I am talk about heat in physics. Heat is the transfer of kinetic energy from one medium or object to another, or from an energy source to a medium or object. Such energy transfer can occur in three ways: radiation, conduction, and convection. In thermodynamics, heat is the form of energy crossing the boundary of a thermodynamic system by virtue of a temperature differences across the boundary. A thermodynamic system does not contain heat. Nevertheless, the term is also often used to refer to the thermal energy contained in a system as a component of its internal energy, and that it is reflected in the temperature of the system. For both uses of them, heat is the form of energy. Heat, an example of formal was informal usage, may be obtained from the right hand photo, in which the metal bar is conducting heat from its hot end to its cold end. But if the metal bar is considered a thermodynamic system, then the energy flowing within the metal bar is called internal energy, not heat. The hot metal bar is also transferring heat to its surrounding. A correct statement for both the strict and loose meaning of heat. Another example of informal usage in the term heat content, used despite the fact that physics defines heat as energy transfer. More accurately, it is thermal energy is that is contained in system or body, as it is stored in a microscopic degree of freedom of the modes of vibration. Heat is energy is transferred to or from a thermodynamic system by a mechanism that involves the microscopic atomic modes of motion or the corresponding macroscopic properties. This descriptive characterization includes the transfer of energy by thermodynamic work or mass transfer. Defined quantitatively, the heat involved in a process in the difference in internal energy between the final and initial state of a system, and subtracting the work done in the process. This is the formulation of the first law of thermodynamics. The measurement of energy transferred as heat is called calorimetry, performed by measuring its effect on the states of interacting bodies. For example, heat can be measured by the amount of ice melted or by change in temperature of a body in the surrounding of the system. In international system of unit, the unit of measurement for heat as the form of energy is joule. As the form of energy has the unit joule is the international system of unit SI. In addition, many applied branches of engineering use other traditional units, such as the British thermal unit at the colliery. The standard unit for the rate of heating is watt, defined as 1 joule per second. The symbol Q for heat was introduced by Rodolphe Colocin and Macquarn's Ricine. Heat released by a system into its surroundings is by convention a negative quantity. When a system absorbs heat from its surrounding, it is positive. Heat transfer rate or heat flow per unit time is denoted by Q, but it is not a time derivative of a function of state, which can also be written with the dot notation. Since heat is not a function of state, heat flux is defined as rate of heat transfer per unit cross-sectional area per square meter. In 1856, Rodolphe Clausius, referring to closed system in which the transfer of matter do not occur, defined the second fundamental theorem, the second law of thermodynamics. In the mechanical theory of heat thermodynamics, if true transformation which without necessitating any other permanent change can mutually replace one another be called equivalent, then the generation of the quantity of heat from work at the temperature has the equivalence value. In 1865, he came to define the entropy symbolized by S such that due to supply of the amount of heat at temperature, the entropy of the system is increased in a transfer of energy as heat without work being done. These are changes of entropy is both the surrounding which loses heat and the system which gains it. The increase of entropy in the system may be considered consist of two parts, as increment that matches or compensates the changes of entropy in the surrounding, and a further increment that may be considered to be generated or produced in the system and is said therefore to be uncompensated. Thus, thank you so much guys for watching this video. Please subscribe my channel and like this video. Bye guys.